Alright, today we're starting our unit on vectors. We're going to do an introduction on vectors and do a couple of velocity word problems. They're actually not too bad. So we're going to be able to write a vector in component form, find the magnitude of a vector, and simplify velocity word problems using vectors. So if you are on your own, you will now watch this cute video clip, or you already have. Hopefully you already have. It's kind of funny. So a vector is an array. This is an array. It's a dot with an arrow at the end, with both magnitude and direction. As so beautifully told to us in Despicable Me. The initial point is this. This is my initial point. We generally want the initial point at 0. So the initial point is A, where it begins. And the terminal point is, in this case, B. Which is where the vector ends. I'm just going to refer to it as it ends. Okay, so this is vector A. Has an initial point and a terminal point. Okay, so there are two ways of writing a vector. So let's say this is my vector A, and it's on a graph. Its initial point is on the origin, the terminal point is somewhere on the graph, and that point is A1, A2. There's component form, which will be written like this. Notice it's almost exactly as a coordinate pair, but now it has like those little greater than, less than signs as its way of forming it. Or you can write it in matrix form, which will be a single column matrix. Okay? And you can actually have a multi-dimensional vector where you have a third dimension or a fourth dimension or a fifth dimension. You can have as many dimensions as you want. In component form, you just keep putting them in order of dimensions, so like first, second, third, fourth. So first dimension is usually considered the x-axis, y-axis is the second, third axis is generally considered z, and so on and so forth. I don't know what the other letters are, that's why I said that. So then the matrix form, you just put them in the column the way they go. So first dimension, second dimension, and so on and so forth. So here, we're going to practice finding the magnitude of a vector, and we're going to be using Pythagorean theorem to do so. Alright, so it says v is -3, 4. So that's basically, it's describing the terminal point for me. So the initial point being 0, the terminal point being -3, 4. There's my vector. Now the magnitude is how long is this line. So we got to use Pythagorean theorem to figure that out. So I know it's 3 long and 4 tall. So the magnitude is going to equal the square root. Well, remember that this is my magnitude. So if I do v squared equals 4 squared plus 3 squared, this is Pythagorean theorem, then I get the magnitude of v squared equals 25. So if I take the square root of both things, I end up with the magnitude of v equals 5. Alright? Let's go ahead and do this other one. Then you guys will practice them on your own. So we're going to find 5, 2. So then there's my vector. So Pythagorean theorem, this is 5 long and 2 tall. So we can just say this is the square root of 5 squared plus 2 squared. So if we do that in a calculator, we end up with the square root of 29. And no, I'm not going to reduce that. Okay? Now I want you guys to go ahead and give it a shot. Do this one here, draw the vector, and find the magnitude.